Problem 4. Class 1 and Class 2 are going on a field trip. Class 1 travels 4 kilometers per hour, and Class 2 travels 3 kilometers per hour. So, unlike last time, the speeds of these two classes when walking are different. The school has also provided a bus, but can only carry one class at a time. The bus's speed is 48 kilometers per hour. If the goal is to get both classes to the destination in the shortest time possible, how many kilometers should each class walk? The first thing we have to do is to draw a sketch and make a ratio of how much they each walk. Because we're trying to get them to their destination in the shortest time possible, and their speeds are different, then it makes sense for Class 1 to walk a little bit more than Class 2 because Class 1 walks faster. The question is how much more? So let's first make a sketch of what this problem is talking about. This is the starting point, and this is their destination. So the first thing that we do is make a sketch of how the bus is traveling. So it's sort of like, say it first picks up Class 1 and then drops them off over here, goes back, goes over to Class 2, and then comes back. And then by the time they drop off Class 2, both Class 2 and 1 are already at the destination. So this is sort of what the bus would look like when traveling. Okay, so this part right here is the part where the bus is carrying Class 1. This bottom part is when the bus is carrying Class 2. And this middle part is basically when the bus is, after dropping off Class 1, coming back to pick up Class 2. So let's first find the speed ratio of Class 1 and the bus. Well, the speed ratio would be 4 to 48. Okay, I don't know if you can see that. Okay, 4 to 48. And then, if we simplify that, dividing each side by 4, we get 1 to 12. So, okay, and then for the walking parts, this would be when Class 1 is walking, this is when Class 2 is walking. Anyway, if we label the sketch with this ratio, then this part, the amount that Class 1 walks, would be 1 unit. And the middle part over here, and then this entire thing that the bus had to travel would be 12 units. So 12 units. Okay. And if this is 12 units, then this middle part right here would be 5.5 units, if you do the math. So we can take Class 1, I'll set Class 1 as A and Class 2 as B. We can set A, the amount that the A traveled by itself is equal to 1 over 5.5 of this middle section right here. And for the middle section, I guess I'll call that from here to here. I guess I'll call that K. So 1 over 5.5 of K. All right, now let's erase that. And okay, I have to zoom in. And then look at our ratio of the speed between Class 2 and the bus. Well, Class 2 to the bus, their speeds would be 3 to 48, and if we simplify that, we get 1 to 16. Oh, and this section right here is still K. Anyway, 1 to 16, meaning that the amount that class 2 walked over here would be 1 unit, and the total amount that the entire bus did was 16 units, meaning that this middle part here for K would be 7.5 units. Okay, so after knowing that, let me erase that because that's not per minute, that's not what we're looking for. Okay, 7.5, and this would be 1 out of 7.5, right? So if this is B, then B is equal to 1 over 7.5 of K. Now we have the ratio of class 1 speed to the speed of the bus. We also have the ratio of class 2 speed to the speed of the bus. Now we can have the ratio between the speeds, between the amount that class 1 walked and class 2 walked. So since it's not exactly efficient for decimals to be our denominators, I'm just going to multiply this top by 2 on the top and bottom, so we get 2 over 11, 2 over 15. Simplify that and we get 15 to 11. Alright, so with this ratio in hand, our final answer would be 15 to 11. That is the ratio of the distance that class 1 has to walk compared to class 2.